Welcome to Ruby Thursday. I'm Melissa Wanish. This is a recording of the Ruby Roundtable meetup, which occurred in New York City on June 14th, 2017. Thanks again to our sponsors, ThoughtWorks for providing space, and Flashpoint for providing food. At this meetup, Matt Jording demonstrated various Ruby tools for machine learning. Enjoy this recording of the Ruby Roundtable.
Alright. So, today we're talking about machine learning using Ruby. We'll be going over several libraries and some introduction to machine learning for Rubyists. My name is Matthew Jording, and I'm a full stack engineer with Flashpoint Intel. Feel free to take stickers and pens.
Thank you so much to them for the pizza.
Yes. Here, pizza. So at Flashpoint Intel, we mine the deep and dark web for intelligence for our customers who are looking for bank fraud, stolen credit card information, jihadist activity, all manner of activity that is, I thought you were beatboxing there for a second. Yeah. All manner of activity that is nefarious on the web. As you can imagine, our days have been getting busier and busier. And we've been leveraging a lot of machine learning concepts. Is this?
Just leave it. I'll try to fix it over here. It's receiving.
So, yeah, we've been getting very, very busy, and we have gotten more and more investment as we've gone on in the past few years. So, of course, we are hiring for engineers and for people who can come up to speed both on full stack engineering and also for the type of thing that we're looking for to be our future. We're driven by human intelligence and analysts, for the most part. My vision for that and what our department is looking for is to augment that in the same way that Kasparov, you guys know who Kasparov is? Right? Chess master, right? He was beaten, he was spanked by an artificial intelligence in 1996, right? Yep. And in response to that, he formed a team-type set of chess players. I believe he calls it the Centaur chess program, in which a chess master is paired with an artificial intelligence system. That pairing has yet to be beat by either artificial intelligence or chess masters on their own. So by pairing a human intelligence, human analysis with the tools that an AI can provide in a symbiotic relationship, both feeding new data to the AI and informing the chess master with that information that the AI can provide, that is an unbeatable pairing, and that's what we are doing in our engineering departments at Flashpoint Intelligence. We are forming tools for our analysts to understand what is an actual alert that needs to go out to our customers and what is a false flag. So that's me. Come and see me after if you're looking to maybe do that for a career. What's machine learning? It's a subfield of computer science, gives computers the ability to learn without being explicitly programmed. It is application development that adapts to change driven by new information. So, like data mining, except the data extracts and pattern recognition adjust the behavior of the program. Okay? You don't need it. Most people do not need machine learning. AI is a hot new buzzword. It is maturing. Most shops will never need it. All right? So if you're looking at it just as a novelty, maybe you want to introduce it to, I don't know, your Shopify account or something, don't do it. All right? It's not for everyone. Also, you have requirements. You need good data. You need well-formed data. You need structured data in order to inform the machine to actually learn from, right? Consistency in your data is paramount, which means that you have to have statistically significant data as well. It means a good amount of data. Most shops don't have that, okay? So you can go to a shop that needs machine learning, but most shops don't need it, all right? What domain areas do we use in machine learning? We have supervised learning, unsupervised learning, and reinforcement learning. Who knows what these mean? Good. You know what the...
No, first two.
Okay, hit me.
Okay, so supervised learning is when you have an idea already what the answer is. Like, you know it's going to be applied to a line and you just need to figure out the parameters.
Right.
Whereas unsupervised learning is when you're just giving the data to an algorithm and expecting it to find some pattern in the data on its own.
Correct. Yes.
And reinforcement learning would be, I see what you did there, hit you, which would be, okay, if you do something bad, then it's, don't do that. That would be, I guess, a negative. Well, it depends on how you look at it. But that is a reinforcement learning. Don't do that, or
absolutely.
Or rewarding yourself, like giving yourself an ice cream cone.
One of the first things that we do, we're doing at our company is a combination of supervised and reinforcement learning, in which we send out alerts to our customers based upon the data that we're constantly searching in the deep and dark web. If this is in fact a valid alert that needs to go out, then we send it to the customers. Guess what? That is a mark of validity. That is reinforcing that pattern of search, right? So we are marking that pattern of search that generates a positive result that went out to our customers with a marker that we can further train algorithms to continually refine our patterns of search for more positive results or better reducing our false positives, reducing our false negatives, right?
Does Pavlov's dog fall into the third?
To an extent, yes. But of course, Pavlovian reinforcement is obviously different in the respect that you're dealing with biological systems.
Oh, I see.
Right?
Yes, that's a good.
Yeah. Which are far more sophisticated than the machine learning algorithms that we're working on. Right? So, what practical applications do you have for machine learning? You've got spam and fraud detection. It's very close to what we do. Get this to full screen. There we go. Spam fraud detection. OCR is definitely a place where we train algorithms to recognize digits, especially handwritten digits, things like that. It's very much a common application. You'll see that in like the standard examples for TensorFlow and other places. Is OCR. Speech detection, right? Being able to recognize speech and accurately translate it. Recommendation engines are rife in the machine learning world, right? So, and that's where you start to get recommendation engines and things like that. You start to see applications for more common shops, right? Especially if you're doing any type of e-commerce, right? You'll want to start doing better recommendations for products for your customers. So you see like shops like Amazon doing a lot of that. Netflix also, right? Medical diagnosis. That's becoming a new and interesting part of machine learning. Better training machines to diagnose an ailment so that you can bring it to an actual expert with a potential suggestion, right? This could be this. Customer segmentation. So breaking up your customer base into segments so that you can better target them in marketing, things of that nature. Putting them in buckets. That can be a fantastic use of unsupervised learning algorithms, right? Because at that point, you can even apply some of the same techniques NASA uses to identify stellar systems with your customer base if it's large enough, because it can recognize patterns and then put them in buckets without any type of supervision or real basis for training. And autonomous routing, so self-driving cars, is becoming a large portion of machine learning algorithms. That is a portion of this topic that I know nothing about. So I'm not going to really talk about how it's being applied in self-driving systems. I have some idea of how that's done, but I'm not even gonna be able to answer any questions about it. So today we're talking about how we can do this in Ruby. There are a lot of libraries in Ruby that we can go ahead and start to use already. And I would love to show you guys some tools to do it. Let's see, this is getting interesting. I'm gonna see if I can bring my environment over so I can do some live coding as well. You guys see that okay?
Yep.
All right, Ruby. There are a lot of great libraries that you can use immediately and start to exercise some of the machine learning algorithms that you're going to learn about. One of which is Classifier Reborn. Classifier is Reborn is a classifier module that allows both Bayesian classification as well as latent semantic indexing. Does anyone know what Bayesian classification is? Yeah? Hit me.
It's a probabilistic method
Yep.
for counting overall. It's kind of basing the classification on how many counts occur for a given category, and
Right.
then saying, looking at something that you want classified then, and saying, hey, how many counts does it have? What then closest matches that probability?
So if you were to say, give me an example, like in real life, say.
Spam classification is used heavily in it.
Yep.
And it will say, hey, in spam, the word free in all capital letters occurs 50% of the time.
Sure.
And then counts free in all capital letters and gives it. But
I also like
again, it does it across all words. And
Absolutely.
gives it full probability.
I like to also bring up Lego sorting as a standard thing that can be a good comparison for what Bayesian classification and other classification systems can be. You have a buttload of Legos like I do in my house. And they're all in a horrible bin, and you want to say put them all in different bins based on a classification system, right? Like, I don't know, 2x8s, and that based upon the pips on the actual Legos. That's something that you can apply a algorithm like Bayesian classification to, right? At least it's a good comparison as far as that type of understanding. So I went ahead and did gem install Classifier Reborn. Okay. And now that's installed. So that means that I can go ahead and start taking some of this and applying it directly. I want to do Bayesian classification here. So I'm gonna Ruby this up. and do a require classifier reborn. And then I define my classifier by saying new. I can't tell if this is.
Do you want R?
Oh yeah. Sorry. Let's at least make it somewhat pretty. There we go. Right. Alright. So, require classifier. Can you tell I've been doing Python for about 3 weeks? Alright, so I got that, and here we are. Great. And you can see the general defaults for classifier Bayesian classification. Category counts, category word counts, stemmers, thresholds, etc. Right? So, interesting and uninteresting, I want to train on interesting. Okay? And you give it the piece of interesting data. Oh, I have to do the array
I
first.
think there seems to be, like, after you, yeah, that thing.
Yep, so I do the classifier Bayesian new with interesting and uninteresting as my data. Then I go ahead and train on interesting with, there we go. So we have good, word, hope, love, that, etc. Then I train on uninteresting and give it some bad words. I hate you. Excellent. So now I can classify very simple things, and it comes up with uninteresting, right? You can also classify on I love. This is very simple. You can actually do some of this classification on, say, tweets that are incoming, right? If you wanted to, you could find something that is a pattern that you wanted to find in all of your incoming tweets. Say you have a GNIP account or something, which is Twitter's fire hose, which I believe they still allow you to get accounts for, but you have to talk to their salespeople. And then you can actually take in a huge swath of Twitter information and say, look for some very suspect jihadist language. If that was, say, your business model. I don't know. And what's a, does anyone know what LSI is? No? Layton?
It's basically sort of like a word embedding model, right? Where you're looking at like how many times, or like co-occurrence counts of words in a document, and so you associate similar words. Basically, you classify them together, I guess.
That's correct. Yeah. So like you start to classify word counts and things in sentence structures that you get, and you start to find the most important word in, say, a tweet, right? So let's go ahead and create a LSI, right? And then we give it some strings in a wonderful array. of arrays. Okay. Great. And then I want to so you can see that there's my strings, and then I can classify. Do I need to put the strings in there? The classifier. Right. Right? Very, very simple exercise in LSI, but you can see like the power of these libraries already just in these very simple examples. You can see you can extrapolate this to far more meaningful data. I'm doing some very simple things with it. Okay? So that's LSI. Another great library that you can use for Ruby, decision tree. Does everybody know what information gain algorithms are? ID3s? It's basically a decision tree algorithm. I think it's so it's also what, iterative. I don't even know how to pronounce it. Dictonerizer 3 is ID3, right? But it generates a decision tree from a data set. You give it a bunch of data, it creates a tree around it. So let's go ahead and install it and start working with it. Simple enough. So I'm going to require my decision tree and then give it a bunch of data in the form of attributes. Where's my cursor? There we go. So this is all written out, but at least you get to see me doing it live so you know it's possible. Right? So you got some attributes and temperature. And I give it some qualification data around temperature, right? To which, granted, this is not Fahrenheit, but Celsius is the rest of the world. So, now I can give it a decision tree and train it on the data, right? So, a decision tree, ID3 tree, new, taking the attributes that I set up, which is just temperature, right? Then I give it training, which is the array of arrays that I set up in the training definition. I ask for sick, and I pass in contiguous as the symbol, right? So there's my data, and then I get to train it. Okay. And now, let's find out if I can predict what that test is. Okay? So decision tree, predict test equals 37 sick, right? Sick. Now, predicted sick, true decision sick. Yeah? We can do the same thing, say, with a test of, I don't know, let's try to confuse it a little bit, right? So I'm going to say 50 is sick when in reality it's really sick. right? So now, let's see if there's a prediction in the decision. It does put it potentially right? And now I'm training it toward a different outcome. Alright, so that's decision tree. And can you guys get the general gist of that? Yeah? Stop me if this at all.
So what's practical application for that?
Right. So, for instance, if I want to give a range of outcomes, right? Say, for instance, I am in a business that I don't know. I want to discover whether a foreign power is exercising some degree of cyber warfare against our voting systems, right? I might go ahead and monitor a network looking for certain IP addresses that are coming from a certain foreign powers set of IPs that are near, I don't know, Virginia, that happen to be a place that is known for spycraft in that general area, right? And if it falls within that group, then it's more likely to potentially be a bad actor, right? If it doesn't, then it's not. So I can give it a range, and I can pipe things into it, right? If it's within this set of IPs, then it might be bad. That's a simplistic thing, but I can also give fingerprint a bunch of malware, right? And malware can go from a huge range of, say, adware, right? Things that are just trying to throw some ads at you so that you will buy some horrible piece of product, or at least have your browser continually go to a page for porn or whatever until you click on something, right? Down to seriously crippling your machine and making it into a zombie that actually is actively part of a malware network, right? So that's a range of relatively benign to a serious threat, and I can give it fingerprints along that range of the various malware that's been identified, right? And by doing that, I can continually have analysts mark malware along that range. Basically, like it's like when you go to the doctor and you're given what is the pain? Is it from this happy face down to this horrible pained face, right? And you can mark that until you get to the place where it's automatically predicting what it is, right?
If I could just add the other very big benefit to this, and actually why it's used in the medical field,
please,
is that
because I didn't know. I was completely talking out of my ass.
Human readable tree at the end. If you see the intermediate step where it shows the actual model, and you see a greater than or equal sign, really sick,
yes,
greater than sign, sick.
So
if
here,
you were to build a medical model that was more complicated, the doctor could get a readout from the model that says they have the mumps, but here were the decisions that were the intermediate steps that led to that. So actually a lot of the newer ones that like use all math and data can't be used by the medical field, because look at an output that says mumps and they're like, I can't justify making diagnosis that I have no idea why. But this model will generate something that they can actually go back and say, these are the reasons why it gave that. That makes sense. I can sign off on it.
Beautiful. That's very well spoken. Nice. All right, and that's the decision tree library. Next, K nearest neighbors. Nearest neighbors is one of my favorites. It stores all available cases and classifies them new cases based on a similarity measure, right? So it basically computes distance between qualities, attributes of things, okay? So, once again, a very simple gem. Install KNN Excellent. At least one of these had a pretty serious brew dependency. GSL, which I think. Right. So decision tree actually had that. So you'll need to install GSL through brew if you're on a Mac, okay, in order to use decision tree. Forgot to mention that. It is important. Right? So KNN. All right. Right, so what am I doing here? I'm feeding it data, which is a new array, 10,000 strong. Right? And I give it data with as a an array of a random number. Okay? Boom. Okay, so that's my data set. Now I want to instantiate KNN. Okay. Actually, let me play that out a little bit. Just so you all see the large set. And then it gives me a distance measurement. Okay? Now I want to find the nearest neighbors within this data set, giving it, as you can see, each of these is 4 numbers, right? Each array. So I'm going to find nearest neighbors here, right? So what I found 2 of them, which I specified, okay? These are the 2 nearest neighbors within this whole set of the data I set. What is the use of that? Anybody? Anybody think of any use?
Question.
Yeah.
Can you repeat the question?
What's that?
Can you repeat the question?
Sure. So I fed it a bunch of data, right? As its data set to work with, and then I specified, hey, what are the 2 closest things within this large data set to this set of data? What is the use of that?
Well, Netflix uses it for recommendation system.
Okay. How?
Okay. Well, how they use it,
Well, I mean, like broadly, broad strokes.
Got it. So basically, say you have a movie and there's a collection of the neighbors of the movie, which might be attributes like genre, or it's like those things become properties of the thing you're actually querying, and then from that, because you don't need that much sensitivity. Like if you can get a 10% improvement upon your neighbors, like that's a difference between like your sales going up 20% and
Yes.
whatnot.
And my actually having Despicable Me recommended Jimmy, or not.
I love it.
I mean, it could also be in the same case, but not for movies, but for the people who are watching it. So, like say you're watching a set of movies, and Netflix figures out that your habits and my habits are very similar.
Correct.
So it could recommend the same movies to me as well.
Yes.
And that could be
And that is, as we mentioned earlier, starts to drift into customer segmentation.
Yeah.
Could
Which,
it,
yeah.
I'm sorry, could it just go into how, like, earlier on, how iTunes had their Genius and
Yes.
your musical...
They still do?
I don't know. I haven't used it in a while.
Yeah.
It's Genius Bar now. You don't go get drunk.
Well, they have that too, yeah.
Yeah, they got that
They have
too.
the Geni, yeah.
So, I would say probably Spotify does a really good job of
Yes.
trying to pair up your likes and whatever data set of other users.
Spotify, Pandora, all that is very much classifying songs by a ton of data, right? And then trying to narrow down those classifications and recommendations.
Has Facebook ever heard of this King Year's neighbor thing?
You know what? Let's not talk about Facebook. It's a sore subject for a lot of things, especially in my business.
You got it.
Yeah. Yeah. Tell you what, man.
Still can't troll either.
You can. Distance measures. Right. So, is this something that... Let's try this. I didn't get this far. We had a little bit of an emergency at work today, so some of this stuff, I didn't try everything, but check it out. So I can get a Euclidean distance of K and N, right? Just directly off of a set of data, right? So this is 1, 1, right? So I'm doing the distance between 1 and 1 and 2 and 2. Okay? I can also check cosine similarity. Yep. I don't know about Jacquard index. So I haven't exercised all this. So that's the index, and then there's Jacquard distance. Does anybody know what Jacquard is?
The Jacquard index is generally a measure of, like, let's say you're thinking of Netflix. It's, I've seen 3 movies, you've seen 5 movies, 2 of them are shared. It's a measure of how close they are together. Saying, hey, we shared 2 movies together. It's a way to expand that until, like, we have a data set of millions of users and turn that into a matrix transform.
As someone who's never actually spoken that word aloud and only seen it in print, did I pronounce that properly?
I have never actually heard it spoken.
He's only seen it in white papers.
Right? Yeah.
With justified text.
Exactly.
I just had a question based on the rating system. How much value does that have based on comparisons or nearest neighbors or anything that you're trying to determine that?
How much value does that have?
Yeah, because you would have all these movies or songs, whatever, they have these genres that have similarities, but say that me and you probably have like the same interests in same musical bands, but we might rate them differently. So how does that play into it? Maybe
they're all play into each other. So like that's the thing, is that you have these automated systems that give you some degree of similarity indexes, right? And points of intersection that you can recommend off of. But then you have to add in all of the other data that your customers give you for ratings and everything else, right? And start to refine those recommendations. I think also what you need to do is do some degree of augmented learning where you're going to have your customers actually define what recommendation methods as well as techniques work best for them, right? If I continually feed you similar users' recommendations, right, and you do not like any of them, guess what? I'm gonna try a different method and promote that above the similar users method, right? And I think that's primarily how most places should do it. Again, some places, I think Spotify is a fine example of good recommendations. Facebook is not, right? In my experience, at least. Of course, I'm not a huge Facebook user, so I'm not sure.
Well, you made a very good point earlier. I think it just now resonated. Is that when you said that you have to have data like garbage in, garbage out.
Yes.
You have to have a good shape of your data as it's
Absolutely.
going. And I would make an addendum on that. What are the questions that you have to ask of your data? Like, because that's a relational database thing even as well, because that's how you know what to index. Like, usually they say, you know, Microsoft coined it as sargeable data. That's essentially what your
Yeah.
index columns.
Sure.
You have to know what you're going to ask of your data to
Absolutely.
know what the index.
Yeah.
And I would assume the same.
So
thing
defining
is going on.
defining the schemas for your data is drastically important. If you do not have consistency in your data, you're gonna have problems. So I would suggest if you're not already on board with like JSON schemas for all of your data, get on board with that.
Like schema.org, you're thinking?
Yes,
Awesome.
absolutely.
Good.
Yeah.
That's awesome.
Yeah. At the very least, all of your APIs should be Swagger, right? It's not JSON schema, but it's getting there, and that's something that you can easily set up. All right. So let's see. Oh, we didn't do binary Jakarta index, right? So that should be 0 according to this. It is. I check the distance. It should be 1. See, this is very simple because I'm just doing straight up integer difference. But Tanimoto coefficient and harvest distance are more granular than clearly the binary set of differences that you've seen in every other distance. Okay? What does that mean? That means that you have a little bit more wiggle room in the distances between that data. So for larger or for smaller differences across data sets, those two things can be more useful. All right. So that was KNN. There's also a great gem called similarity. Calculates the similarity between pieces of text using some degree of term frequency and inverse document frequency methods. Okay? So let's go ahead and install that. Excellent. And start to use it. Requiring similarity and giving it a new corpus. Okay. I want to give it a document with some new content. Okay. And here is the entirety of my document's content. A document with a lot of additional words, some of which are about chunky bacon. A little shout out. Have I caught the chunky bacon? I'll get you a drink next time. Reminds me, we should have another Y day soon. Again, anyone who gets that. Well, the internet's a beautiful thing. Right? Many words, again, about chunky bacon. Okay, and I have a third document. Guess what that's about? Nope. It has nothing about pork products at all. Right? So, with this, I want to put them in an array, and then for each, I'm going to shovel in each doc into my corpus. Okay? So now I get some term frequency in there. And now I can check for similarity. Just gonna grab all this. Don't mind. So now I have similarity between. Where we go? Similarity between this and this doc is 1, right? So 703.
Same document.
What's that?
It's the same document.
Yes, exactly.
On my computer, it's only 0.99911.
Is it really? That's fascinating. I wonder what the difference is. But,
Faulty processing.
possibly.
What Ruby version are you using?
Oh, that's a good point. Yeah. I am
Math
using the
got
most
it.
current.
Yeah, and math got an upgrade.
It did.
recently. Believe me, in the old Ruby, there was such thing as -0 or things like that.
Let's not talk about it.
Wait, so are you on 3?
Oh, no, I'm not on the leading edge. I'm not on Edge yet.
Oh, okay.
I'm on the production edge.
Is that who you're not?
3 is not out. Is it? I think it's in Edge, but
No,
that's it.
Free now. Not that I know of.
Yeah, I could be wrong. I've been wrong before. Alright, so, similarity between, yep. So that seems to be, seems to jive with the presentation. Sounds good. Alright, and I can do a similarity matrix of the corpus that I built. Right? Just gives me a nice output of all of that data. Okay. And you can see that maps pretty well with the 0.06, what was it? 0.06, 0.04, and 1, right? So you can see the difference from, right? K-means clustering. Vector quantization from signal processing. Does anybody know about signal processing at all? Yeah? Talk to me about
I'm working on a WebRTC project where it has like a audio graphic visualizer.
Nice.
So it gets like this stream that comes in the channel, and I don't know how it does it. There's some magic, but there's like this audio node inside of the browsers now, and you use
Yes,
that.
there is. Yeah, Firefox has been leading a bunch of stuff. If you get the Firefox Developer Edition, which I think you all should,
Yeah.
you can start playing with a lot of that stuff.
Exactly. There's tons of stuff in the browser now, and it just takes the audio as data points. That's when I really learned that our voice really is just a frequency, meaning it's just like
I mean, some are.
points.
I'm basically torn up. So.
Yeah. But being able to see it, like,
Yes.
that's the weird thing, because it's like these numbers go in, and then you see like the visualizations that come out of it. But I don't think that's learning very much. So.
No, it's data though,
Oh.
right? So, signal processing. So cluster analysis and data mining, and that's where you start getting into a lot of the K clustering that is done with stellar identification, and all of that information. Anyone have any other info on the background for K clustering? Otherwise, I'll just go into what we can do with it. Nothing? Okay. Cool. We got 2 gems. We got K-means cluster and K-means. Right? So K-means cluster. I didn't put my gem install or nothing on it. Alright. So K-means cluster. Oh, what?
It's probably going to be the hyphenated.
Yeah, let me look it up.
Wire.
Yeah, it's the same. It's probably the same as Finquire.
Yep. Yeah, there it is. See, this is what I should compare slides. And spell things. Do I have the prerequisites? Hey, look at that. That's good. Alright, so now I can go ahead and do my pry, do my require. And feed it some data. What type of data am I feeding it?
Location.
Let's longs, yep. So I got some lat longs in there. And I want to label those. So give them some labels. Alright, yeah, New York, Los Angeles, Baltimore, Portland, etc. So now I want to find two clusters in data. So I define k equals 2. And then I go ahead and run a k-means cluster on it. Running k, give it the data, give it the labels, and give it runs, which I want 5 on, okay? Excellent. So I got 2 iterations on it. Error in my runtime. Feed that. So you can see now Los Angeles, and Portland. Here's my ranges. Baltimore, Washington, DC, New York. My ranges. What use is this? So I've given it a bunch of data, which is lat longs, gave it some labels, and asked it to cluster it into 2 buckets. Okay? What have I defined here? I've defined a war between hip-hop in the 90s and 80s. Am I wrong? I am not wrong.
You're right. You is or you're right. Oh no, Baltimore's kind of questionable.
Yeah, Baltimore. Yeah.
But the Wire is good, so I mean,
The Wire is
that
good.
kind of gives, that's almost a hip hop album.
So yeah, I've separated it into 2 sections of the country, right? So I can do that further and further define large disparate sets of data. Right?
So I was reading here, and it's Google says. So first, can you tell what do you know about Gaussian distribution?
Sure.
And they said that that this is actually one that's it's a good one for people to start off with because it's like one of those things where it's like you want to learn this, but you don't want to use this in production kind of thing, unless they said you're using it for the input to another one that's a more like tighter search or something like that.
I can give you first off I'm gonna ask the graphic artists in the room to tell me about what Gaussian means to them.
Gaussian?
Yep.
Blur.
What does that mean?
Smudge.
Okay.
How deep would you're asking for the graphic design answer.
Yes. See, I'm just because
So
there's two categories of life that you're gonna find the word Gaussian come up, and that's in your Photoshop.
Well, it's a
and
Photoshop,
the other is your probability theory.
If you want the designer answer, it's a really overused Photoshop filter.
What does it do?
Damn it! I just used it today.
What does it do?
It essentially takes an image and stretches it out in a way that adds a slight blur. It looks like it has a slight blur to it. A lot of people use it for motion lines or speed lines or some type of speed effect because it makes the image look like it's moving.
Excellent. Now, probability theorist in the room. Anybody who took probability, tell me what Gaussian means.
It's the bell curve.
Yes. So
It's also how the Gaussian blur happens.
Yes. So let's bring that together. How does Gaussian blur happen?
It takes a pixel or a point and then uses the normal distribution, the Gaussian bell curve, to then take that point, take all the points around it, and then does it take the average of the points around it? Is that basically? Yeah.
I believe so. Yeah.
I think it cuts off the ends of the bell curves more as you like move the slider, you know.
Oh, that's the adjustment.
So it basically takes the average like tighter and tighter to the center.
Right. So I think everyone in the room has some degree of understanding of what Gaussian distribution means now, which is a wonderful thing.
So why?
Even Todd does.
Yay! So why is that? Do they say that's to know that is a prerequisite to know?
No. No, it's just the way that your distribution is calculated, right? So what we're doing here is we're basically grouping two sets of a large distribution of data. I can give I can give this k-means cluster. It just takes that distribution, applies that distribution across, but then cuts it off into sections, right? So you have I just give it a grouping of twos, right? Whereas I don't know if I
Be careful adjusting those numbers, man.
if I clustered it by 3 or whatever, I could possibly get Midwestern in there, something. But I don't think that my I'm pretty much on the coastal sides there, so I'm not going to mess around too much with it, right? But you get the idea. If I had even more lat longs in there, I could get Milwaukee, right? And Milwaukee would be in that third grouping. Okay?
Can you have like a third grouping here as well, but it would be like
South and
it'll be like Los Angeles and maybe Vegas together. Portland would be separate.
let's give it 4.
It's basically looking at
Because I
like
think that
central
actually
areas.
would distribute better if I give it 4.
Yeah.
If you get it at 3, it might do longitudes.
Yeah, what the hell?
Like across, you know what I mean? Like the topmost, the middlemost, and the bottommost.
But,
because
like-
you're doing Portland, what was it? Portland, Vegas, and
Portland, Vegas, and Los Angeles on one side.
If you put a
Vegas and
semicolon
Los
after
Angeles
the
are so
end,
close that it might
What's
be
that?
better.
if you put a semicolon after the end, you won't get all the other alpha, just the puts.
Okay. So if I just do this and then give me a semicolon on the end, like so.
Yep.
Yep. Nicely done.
Yeah, so I told you Portland like separate.
Right. So what do we got? We got Portland, Baltimore, Washington, New York, and LA and Las Vegas. So it's basically separated the West Coast into 2 groupings, north and south.
Yeah.
Right?
Because Baltimore, Washington, and New York are close
Yeah.
together.
Correct.
Had you done like 4, maybe it would be like Baltimore and Washington would be closer. New York would be separate, Portland would be separate, and then Los Angeles and Vegas might be different.
See, so the machine learning can be fun.
I mean, it's looking at the centroid, right? Like the
It is.
distance between the 2 points.
I wouldn't be surprised if Los Angeles and Vegas might even be second.
So that's 4. In New York,
So basically,
right? So you can see how this can start to segregate your data a little bit more discreetly, and you can actually get some meaningful clustering of a large set of data. So that's k-means cluster.
I see how this is a prerequisite to even further operations that you can send to that new service.
Well,
Yeah,
also,
and-
let's
yeah.
predict a middle point, as I was talking about, with Chicago.
So the other piece that you're talking about it being used as an intermediate step and not a final answer, is it's an unsupervised learning problem. So if you're giving it, say, hey, I want 4 clusters coming out, depending on your data in, those clusters could be completely different.
Right.
Like, think about if your data was really dense and you had points all over the place, it might cut them one way one time, you add some more points, and then it cuts them slightly different. But it doesn't give you a qualitative answer. It doesn't say, I made these cuts because this is
Because it's unsupervised.
like this is what moms want and this is what the college student wants. No, it just makes arbitrary cuts that groups them together. And so it's great for another step because people run k-means clustering and be like, give me 4, and then put that into another model and say, hey, this landed in the same group as these.
Yes.
Now use it as
So that's what I just did here. I defined Chicago. I went back to the 2, right? Separation of 2 clusters. And then I defined Chicago, had it predict what group it's going to fall into. And it fell into 1. Right? So it fell into the Baltimore, Washington, D.C., New York side of things rather than the West Coast.
So would this be a good tool for like maybe like a raffle or something like that? A geolocated raffle
It's
as opposed to with random with air quotes?
what I've seen people use this for, and it'd be really good, is explore exploratory analysis. Like you're running an e-commerce store,
Yes.
and you're trying to segment and figure out, hey, what are people buying things together? Like,
Yeah.
hey, all these people buy these group of items together. That's one.
Or say you're analyzing a bunch of buying habits of people on Alphabet as they are exchanging Bitcoin for synthetic marijuana.
Yeah.
So specific. Interesting.
Say that's part of your business model.
Okay. Can we at least say legal marijuana or something like that?
Well,
That
whatever.
works out
Yeah.
pretty well.
Yeah. There's plenty of places. Well, all right. So let's go with straight up cocaine then.
Okay.
Right? Something that's illegal in all 50 states. All right. And you want to help out law enforcement to figure out like where the largest ring is in or the largest ringleader of distributed cocaine on the internet, right? And so you want to find out who's supplying all these things. You want to find out who is talking to whom, and then eventually does the purchase.
That sounds like a multitude, like a sort of a cornucopia of all of the
It's a bunch
methods
of
that
things.
you showed before.
Yes, it is.
Dishing out some secret sauce.
I'm not. Standard stuff for the most part. All right, so K-means. Is another library. Let's do our require and exercise that out. We got some data here. Nice little array of arrays.
You copied over the.
Yeah. We'll try that again. There we go. And now we want to do a k-means new and give it a centroids of 2. Okay? So this is similar in the respect that I'm grouping things together by their means and separating them into 2 buckets, which it did handily 0, 1, and 2, 3, 4, 5. Alright? Simple. So now I want to give it a different distance measure, but keep the centroids at 2. So I give it Jacquard index, as we saw earlier. And now I got a bucket of all my integers and a bucket of nothing. I want to do the same thing, but I want to give it Habersign, which is again a little bit more precise, a little bit more granular. Habersign? I feel like it should say speech, but iTerm really has to up its game with Mac integration. It should be able to speak to me, right? Let's try it in here.
Just use the same utility on your Mac.
What? Oh. Anyway, K means new, Habersign. So what do I got? Why did it do that?
Delete. I don't know, I took the middle one out.
It did, it took the middle one. Sort of. Not so much the middle one. Middle one of the first bucket. In the first mean centroid. So I basically defined 2 centroids, and I defined different Habersign distance. That Habersign distance centered on 4. Oh. So I guess that's it for K-means. Yeah, we're getting close to the end anyway. So I would suggest you all look up these terms and explore them a little bit further. Artificial neural networks, this is where things get a little sticky. Ruby's got a very nascent exploration of this type of stuff. Luckily, we do have Cerebrum. Nice. So, gem install. Nice. And let's require some stuff, and then we can train it with a new network. Excellent. So I'm going to give it a new network, and then I'm going to train that network with a bunch of data. I know absolutely nothing about this library, except it is the first exploration I've seen of a Ruby infused artificial neural network definition. I've done some stuff with neural networks, but not at all in Ruby. Okay? You can see here that I am training it with some inputs and outputs, and then I'm given that information to hold on.
You're teaching an XOR.
Yes. Tell me about it.
If they're different, you get high.
Yes. I don't know what all I can do with it after I've trained it.
Try maybe run LS. Is that to get the list of
What did they get?
Good call.
what?
LS network? Yeah?
Maybe.
Okay. So we've got biases, deltas, errors, and we saw some of that come out, right? We got an error and iteration on it.
So you've trained it, and now I guess you could run it and give it a 2x2 array. I mean, like an array, an XY array.
You have to do network.run and then give it an array.
And what am I giving it?
Give it an
One,
XY.
1, comma 0,
Yeah.
and we're expecting 1.
Close?
Right, it's a prediction.
Yeah, absolutely. Okay.
You can give it anything that is 0 or 1.
0, 0 should be.
Close to.
It would be
Close to
interesting.
1.
It would be interesting to give it like 2 to see what happens. What?
Interesting.
You give it a 4? No, 3. Sorry, 3.
Sure. Yeah, so it's going to drift further away.
By another magnitude. Oh no, that's wrong.
Wait, if you give
No,
it 3 and 3?
That's right. That's right.
What's that?
If you give it 3 and 3?
3 and 3?
Yeah.
Yeah.
It should be.
Yeah. Doesn't make any sense.
Yeah, that doesn't make sense.
Yeah. So I'm not sure. It's something to play with, though. Right? I suggest go ahead and install that gem and start playing with it, because it actually is the first thing I've seen of any artificial neural network playing with Ruby. And I would also suggest looking at the source of all of these libraries.
Yeah, especially what happens when it's not 0 and 1. That would be really interesting if that. Because I expected it would.
So what did you used other libraries? So what did you do in those libraries? Like with the artificial.
Oh well, this is a whole different animal, though.
Okay.
So running a neural network and prediction model on data. This is the portion of my presentation I did not prepare, but I wanted to at least make you guys aware of it. Okay. So Cerebrum. Other things that you can play with. Has anyone played with OpenCV? OpenCV is awesome. Why is it awesome?
Because you can see stuff.
Because it can see stuff. Yes. It's computer vision. I use OpenCV because I am a Dungeons and Dragons dungeon master, and so I've hooked up a Raspberry Pi to a dice tower, and it takes a picture of dice after it rolls, and determines what type of die it is and the actual value of the die roll. I'm using that to pipe to Twitch.
Nice.
Because I'm an idiot. So use Ruby OpenCV. It's available to you. You know Ruby. Work it out. TensorFlow. Who knows TensorFlow? Who knows of TensorFlow? All right, cool. TensorFlow is great. Google is using it for all of its machine learning libraries in the cloud, right? And it is open for you to use. So install it and install TensorFlow RB to give yourself a nice interface to start working with it. You can start actually doing a lot of the things that we're doing in a very vast aspect, including understanding like both sentiment analysis as well as salience scoring on text, which gives you the most important words in a sentence, right? Or paragraph or paper, right? And that can be very valuable depending on your business model. That's all I really have for today. Right?
OCR too. So you mentioned OCR earlier.
Well, OCRs, you can do OCR with OpenCV.
But I thought OCR was Google's thing.
So Google has OCR stuff on it too, yeah.
I see.
Right, so optical character recognition, right? That's something I'm using in OpenCV, right, to read the die values of a rolled die.
I see. So OpenCV contains OCR tech.
It's image recognition, right? So with OpenCV, you can also, there's a great video on that's like 6 years old, taking FFmpeg and OpenCV, and basically taking a video and then piping it through with some Ruby image magic, right? To add a hat on top of everyone's head in a video.
Yeah, that's for sure.
Yep. It's a good talk.
I used this library one time with like a Raspberry Pi and a little camera to just like count the number of people in a room.
Yeah,
nice.
Absolutely.
So it's a pretty flexible library.
Oh, it definitely is.
Yep.
I used to get my students.
Yeah, nice.
Off a night. I'm not even kidding. They used to
All right.
I'm not kidding. They tweet out an image of a shoe, and on the back up, they have a bunch of words behind the shoe. They're hashtag words, and they say the one that is actually circled, you have to be able to take that word and tweet it to Nike through Twitter.
So you're defeating a CAPTCHA style human recognition.
Yeah. But
With OpenCV.
It had to be through email, though. So you had to also parse the email through the Gmail API to send Twitter a tweet.
See, that's just as dumb as my Dungeon Master thing. Yeah. Well done. Sneakerheads are just as bad as D&D nerds, I'll tell you that much.
That's true.
Alright, so that's my entire presentation. I hope this all was valuable. It's a great introduction to using machine learning in Ruby. And I expect all of you to start training software to do your job. Cool.
Thank you guys.
So have you actually used any of the Ruby libraries in a production application?
Not in a production application. Right, but I have used it to train a lot of us up on the methods and techniques for that we're starting to use. A lot of the production applications we're using just cloud libraries.
Okay.
Right, but getting to the place where we understand what. Yeah, we use it all the time for notebook style sketching of what we want to do with data, what we want to find out about our data, and what techniques we can apply to our data. Right. And that's super important because I can go ahead and take a sampling of everything we have, pop it through something on the command line, and start working through a lot of these problems so that we start to get a sense of, okay, if we apply this technique to this type of data, then we can start getting closer to better suggestions for our analysts. Right?
So is there an equivalent to like Jupyter or R notebook in Ruby?
No.
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 There's
I don't think is Juniper doing Ruby yet? Because I assume that they would as well. But I mean, like, that's the thing, is like a lot of these things that R notebook and Juniper notebook and things like that are doing, Ruby just does naturally, right? So.
Is there a reason that it's not used in production? Like
Just our shop language preferences for production data,
Yes.
right?
A lot of these libraries don't, like, if you notice when you generate them, you see that, like, the intermediate models are saved in, like, hashes and things like that. It's that people in the Ruby world haven't spent the time to say, hey, I don't want that in hash, I want that stored in Postgres or Redis, so that, like, it can store thousands, millions, whatever, without having to deal with, hey, I need that much RAM.
Yeah, there's no reason why you shouldn't be playing with it. Yeah,
Pull requests are accepted. Right?
yeah, absolutely.